Hello everyone, welcome back to my channel. Today we are going to solve another interesting problem from Green 169 Total DSA Problem Tracker. Till now, I have already solved problem from the different categories like arrays, linked list, matrix, and we are almost on the last phase of the interval problem. In the following session, you will be seeing different types of problem: two pointers, sliding windows, string, tree, if, backtracking, stack, try, graph, a greedy algorithm, advanced graph, 1D graph, 2D graph, dynamic programming. The things which I wanted to bring on the table. So when you see the problem statement, how you understand the equation behind the problem statement, what is the use that how we can solve the problem. So once we are able to build a brute force approach, like the basic way by which I can get the output, there are different way how we can optimize the approach. We'll see in each and every video you will see the similar kind of pattern. So without further ado, let's get started with the meeting room 2. In the previous video, I have already solved the meeting room first. If you wanted to get inside of that, I highly recommend you to please watch the video which I already recorded, and you can see the video in the description for this. Now let's try to understand the problem statement behind. So for example, you are given start and end, such that start I is the starting point of ith meeting and end I is the ending time of ith meeting. Remember the minimum number of rounds required to attend all the meetings. So if you have seen my previous video where I was trying to explain how many meeting rooms are required in order to whether the you can attend all the meetings in single room or not. Okay. So in similar way, we have to find whether we can attend all the meetings in one room or how many rooms we required. So just to add on the previous problem. So if you understand previous problem, if not, I highly recommend you please go and watch that video so that you understand how meeting room first problem has been explained and how we can solve the problem. Now let's try to understand its intuition behind this problem. So we have given two start and end. So I will just try to write start. It's 296 and end is 4, 12 and 10. So I will just try to draw on the line so that you can understand. So this is 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So I will just try to draw outline 2, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Okay. So my first meeting starting is at 2 and will end at 4. My first meeting will start at 2 and will end at 4. Okay. My second meeting will be starting at 9, will be ending at 12. My second meeting will be starting at 9, will be ending at 12. My third meeting will be starting at 6 and will be ending at 10. My third meeting will be starting at 6, will be ending at 10. So these are the three different meeting rooms I have. And what's the important thing which I wanted to solve? That whenever I'm crossing the limit, I'm crossing the meeting. So in that case, I won't be able to attend the entire meeting in the same room. I need to find a different room. That's what the expectation from this problem. So for example, if I'm starting the first room at, for example, 2 o'clock and then its meeting is getting completed at 4. So 2 hours is there, and between the 2 hours, the meeting can get completed. There is another meeting which is started at 9 p.m. and can get completed at 12 p.m. 12 a.m. So in that case, there are 12, 3 hours gap by which the meeting get completed. But if we see the third, like it started at 6, but it is ending at 10, and the second meeting starting at 9. You can see there is a clear overlap, right? There is a clear overlap. So when we see the clear overlap, it indicates that the that meeting can't be conducted in the same meeting. We have to find a different meeting room for that. Okay. So quite easy. So what I will do, what are the criteria by which we can say that the meeting is overlapping or not? Simple, right? The meeting should be start, right? For example, if we just compare these two, right? This particular meeting and this particular, right? Or the starting meetings, which is overlapping. 6 and 10 meeting is overlapping with 9 and 12, right? So 9 and 12 will be joining in between. So I will try to complete this particular meeting start time should be after, right? This should be meeting, this particular the meeting which we want to compare should be start first, and then second meeting should get started, right? And the important ask is the second meeting's starting time should be, right, should be less than, right? If it is greater, right, if it is greater, then the meeting is already completed and you can already, for example, it's here, right, 11. So in that case, the meeting is already get completed. So second meeting start time should be before the ending time of the sorry, ending time of the first meeting. So it's simple, right? What I can say, I can think about starting of first meeting, right? We can consider, we can consider I and j. I is equal to 0 and j is equal to 0. We can think about these are two variables. So I have to check for each and every, each and every iteration, each and every intervals whether I can find an overlap or not. So for example, if I'm starting here, okay, I will try to find whether I can find overlap for this or not, and then I will move for this, right? Then I will move for this. So in that case, I won't be able to get it. But when I'm moving for 9, right? When I'm moving for second interval, in that case, my I is equal to 2 and my j is equal to 1, right? I will start from here. So is there any overlap happening? No. How I can take the overlap, right? So my starting point of the first meeting, my starting point of the first meeting should be less than or equal to my current time. Okay, so if it, for example, the second point is starting at 2 and it's starting at 9, so it means that my condition is getting fulfilled. And the important thing is that when we can say the meeting is getting overlap, ending point of second meeting, right? Ending point of second meeting, this is J, right? So this ending point of second meeting, you can say ending point of second meeting, right? For example, ending point of second meeting is his, so it is getting overlap. How we can know that? It should be greater than with starting point of first meeting. Okay, so if I will just just take like for a 9 and 12, right? So I will compare here. I don't get anything completely, starting is 2 and starting is 9, so it's completely in that. But ending of j, so when it does it ends 4, right? Is it greater than 9? No, right? So in that case, it won't be considered as overlapping, so I will not be increasing meeting room. But when we start here and when we see like 9 and 12, so anyway, like if we compare the same parameter, then it's definitely going to be the same. But right now, my I is my I is at 1 and J is my 2. So my I is 2 is 9 and 12 and J is 6 and 10. So if I compare these two, so what does it indicate for me? So, right, I will be compare this start and this. So for example, 6 is less than, sorry, 6 is less than is equal to 9. Yes, it is. And what I'm comparing, this ending point of second element, right? Ending point is 10. Is 10 greater than the starting point of first? Yes, it is. Once we found this, then we can easily say that the meeting is overlapping, and in that case, we will increase the meeting count, increase the meeting room count. Okay, and in the last, for each and everything, we can do the comparison. We can come up with whether we can have a similar, how many maximum number of rooms we require in order to get that. So let's try to solve this problem on editor. So what I required a couple of variables to be declared. What I required, start, and I can do it internally, but I required room equal to 0 and maximum room, max room equal to 0, because I'm declaring, and I have to make count that. For I will try to move along all those. Also need to declare n. Okay, then I also need to find it, and I'm doing comparison for each and every. I'm not skipping anything. Okay? But when we start the next iteration, we have to make sure that the room count is setting 0. So I will just make sure that I am setting 0. And right now I will just add the condition. What is the condition? Starting of second second interval starting point should be less than equal to starting of first. Okay, should be equal to less than starting of first, and my starting of first is should be less than ending of second. Okay, once this condition match, right? What is this condition match? What I will do, I will increase my room count. Also, once this is done, right, we have to make sure we have to maintain the count of my maximum. We have to maintain the count of maximum. So what I will do, I will straightforward increase the count where where I will just try to find whether the room is getting maximized or not. So once this is done, once this is done, once this entire loop is getting completed, because I'm having loop count at the set at the for the entire iteration. Once this is done, then I will try to find whether what is the maximum room size I can get by doing all those, right? Maximum room is max room, then, and we just have to get the finding. So I will try to return the, and let me try to check whether it's getting accepted or not. I think yes, it is getting accepted. Let me just try to do some input for that, and it's they use the same example like we were using 2, 9, and 6, and in the second we were using like 4, 12, and then 10. Let me just try to submit this. I think yes, we got the 2 room because we were getting the first room and second room. Now think about the time and space complexity. Time complexity and space. What is time complexity for this? So clearly you can see we are using first loop and then we are using again second loop. Clearly it's off and square on average. We required to be do the transaction for each and every element twice. Off and square. And what is space complexity? Are we using any different data structure to process and store? No. Space complexity of 1. Now thinking about how we can optimize, right? Thinking about how we can optimize it. We got a solution, but what we are doing, we are just doing the repetitive comparison for each and every element. But I don't want to do the repetitive comparison. What I want, I can do the comparison in one go and I can get the answer, right? Just wanted to get the repeat. I don't want to get the repetitive comparison. What I will do, in spite of just doing that. So if I will just go to the here, what we were doing the comparison for this one. We were doing the comparison for this one separately, and then we were doing the comparison for this one alone. This one firstly, this one. So we are comparing this and this. Then for this we are doing the comparison for this with this with this and then with this. Again for this particular we are doing comparison with this. So what we are doing, we are just repeating the pattern again and again. Okay. So for this, what we're doing, we are just doing the comparison for this one first, then second, and then third. When we move to the second, we will do the comparison for this, and this. When we move to the third, we are doing comparison this, and this. So 3 comparison for each and every element. So I don't want to, how I can reduce that? So if you see the pattern over here, what was the comparison factor? We are moving I and J, right? Likewise, so the starting point we are continuously moving, right? If we see like we are starting firstly here, then moving ahead, then moving ahead, right? But if we do the comparison on the basis, right, and if we have the exact neighbor, uh, sitting neighbor, the ascending order neighbor nearby near, compare only the ending parameter. Starting parameter is anyhow in, and it will increase as and when we are increasing. So what I will do, no, the comparison, doing comparison by just having the array in place, difficult because I won't be getting the starting point, ending point differently. It would be different at sitting at any. So what I will do, the first ask for me is that I just need to sort that out. So I will sort it, both of them. So what it will be now? So it's 296. So it will be 269, and then second will be 4, 10, 12. So it will be 4, 10, and 12. Okay. So if we do like this, then I will again try to draw the line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so my first meeting will start at 2 and will end at 4. My second will be starting at 6 and 10. My second will start here 6 and will be ending at 10. My third meeting will be starting at 9 and will be ending at 12. So here you can clearly see, like here you can clearly see that as and when we are moving from first to second to third, we can easily able to get, and we don't want to do the repetitive competition again and again, because we are doing repetitive comparison again and again. What I will do, I will start from here and I will try to see whether the ending of this is greater than the starting. It is, right? It is. When I found that, I will straight away increase my room count plus 1. Okay, I will straight away increase my room count plus 1, and I will just make sure that as and when I'm getting the room, I will set the maximum room count. How many? So I will set the maximum room count to maximum room is equal to 1 when I is equal to 1. Right now, what we are saying that we got the count, so I will just increase my I so that my ending point should be fixed. Okay, ending point. Right now I am here. I will try to compare. Okay, whether my starting point is less than my ending point. My ending point is here. It is no. If it is not, what it means that the room which was previously used can be used again, right? So what I will do, what was the room point was there, so I will just try to decrease that room counter, because I'm not going to use, I can use the same room again, right? I can use the same room again. So I will come here, both the right I and J will be here, and J will be here on the same iteration. I'm not doing the repetitive one. It just how you can use the if condition, that's how it matters. Okay, right now my ending is here, my starting is here. So what I will do, I will do the comparison again, right? When we do the comparison, where was my I was here, J is here. Right now what I will do, I will do the comparison, and when for example 6 is less than 10, yes it is. So my room will get increased to 1, and once room is get increased, I again set the maximum count. Now I will move my eye to the next intervals. Next interval is 9 to 12. So what I will do, starting point of the next interval and ending point of current interval, right? So it's 10. Sorry, it's 10. So it is lying, yes it is lying. It means that I will increase my room count, and I will just make sure that max room count is also getting changed, and I will try to move after, right? But it's the last point. It's the last point. So do I need to do the consideration again? No, right? I don't need to do consideration again. So if we are doing the sorting of it, if we are sorting it, then it will be quite easy for us. It will be quite easy for, because all the comparison can be happen neighbor to neighbor. I don't want it to go first and last. I can do the comparison for anything on that line itself, right? So the first important task is to just sort it, right? So just first important task is just sort it, and once we do the sorting, then trying to compare the starting point of the first interval with the ending point of the that interval where it is. It can be start from the first and second. So we definitely required I and j, but when we can increase I and j, it's when the comparison is not working. Means starting of the first interval and ending of the second interval is not less. If it is greater, then it's definitely second room, and in that case, we can use the same row again. So I will just try to write the code for that. I will just clear this entire room. And first thing is, I just definitely need to sort it out. So I will just do the sorting of it, and then okay, then so end dot begin, end dot end. Okay. What I required room to be 0, max room to be 0. Then I also required I to be 0 and j to be 0, so that I can do the comparison. Until when I need to move my iteration, until I is not until I is less than n. It means what it I is my starting point, right? For your information, I is my starting point. Right now, I will just try to write start of I, right? With whom I wanted to compare, end of. That's where I can see, like, if starting from first, I will try to compare the element where it started. So in the first go, it's pretty straight that it will be, because 2 4, 2 is my starting point, ending point. When I move my I, it will be 16, but only I'm moving my starting point. So in starting point will be 6, but ending point was the previous, so it was 4, and I will do the comparison. So if this condition match, then I will straight away increase my row count. Okay, I will also increase my I, and also make sure that what is I will just make sure that the max room count should be set using the max room and current room. But if it is not matching, what it indicates that the room which we were using initially should get used for the next one, and we could use that for the next iteration, and we could also j is increasing because that particular interval is already gone, and we have already allocate the room for use meeting purpose. Once this is the entire transaction, I will just return the max. Let me just try to submit this. Let me just try to whether it's working or not. Yeah, so it's saying that there is a typo because we have given some extra space, and we didn't declare the n as well. So I will just declare the n. Now let me rerun it. I think it is getting accepted. Let me try to submit it now. I think yes, it got accepted. Now let's think about the time and time complexity, and space complexity. So what is the time complexity? So here we are doing the sorting, right? We are doing the sorting, and then we are moving, from I to n. So I is starting from 0 to n. We are kind of saying that for sorting, the time complexity will be O of n log n. And also we are doing the complete iteration over a loop. So it's O of when considering n is the number of size in start and end vector. What will be the highest between both of them? The highest is O of n log n. N log n. What is the space complexity? So Though we require some space, in order to sort internally because it's using stack space to do that, but we are not because it's the function which is already inbuilt. We are using that. Other than that, I will require anything to store and process. So space complexity of one, right? So I think with this we will conclude this video, and we'll try to see the video in the following session. Thank you. Bye bye.